Hello, everybody. Thank you for joining us in another Tech Talk tonight. Tonight, we have Andrew Widjaja, and he'll be talking to us about testing tools and frameworks. Before he begins, let's all unmute and give him a round of applause.
Andrew.
Thank you, everyone. Without further ado, Andrew, take it away.
Thank you, Simon, for the introduction. Today, I'll be talking about testing tools and frameworks. Before I begin, I'd like to thank CodeSmith and SingleSprout for sponsoring my Tech Talk. So there's been a recent explosion in innovation in the testing space, and I won't be going over the best practices of testing, but rather the types of tests you want to consider, as well as a brief overview of the different tools and frameworks you can use as you consider implementing tests for your own application. So to start off, what is a test? Any test at its root is a set of inputs passed into a function that will return a set of outputs. And we need to match our expectations against that output. So it's a simple Boolean of whether or not the output matched our expectations. Here we have a simple function that adds two numbers together. We expect the result on line 5 to equal 7. So that's something we could write a test for. In the front end, we have components, which boiled down are still functions. So the logic remains the same. And so you might ask, when are tests needed? So imagine you're building software being used in a rocket to send humans to Mars, or a medical device keeping a patient alive. These software have little to no room for error, so you better believe you'd be writing tests for every edge case imaginable. Okay, Andrew, but you're building a website for selling cute Japanese erasers, not sending humans to space. So letting some bugs slip through is fine, right? Well, now this is where that trade-off becomes more interesting, because we may not need tests. And now testing becomes more of a business decision. Does it benefit my business to ship features quickly and consistently? Okay, then maybe I don't want to tell my engineers to spend so much time writing tests. Or is there a crucial front-end code that directly influences the conversion rate on my website? Well, then I should probably write tests for that portion. The tools and frameworks I'm going to discuss today are there to help make this business decision a less painful one. And the tests you write and the tools you use will depend on what level of the application you'll be testing, from individual functions to the entire application flow. The three main types of front-end tests are units, integration, and end-to-end tests. So let's start by testing the most basic building blocks of an application using unit tests. These tests are focused around the functionality of individual components, functions, methods, and components. And one of the most functional frameworks to use is Jest, which was developed by Meta, formerly Facebook, and continues to improve considerably. It's a JavaScript testing framework that provides global functions and features that make it relatively easy to read and write tests. So let's revisit our sum function from earlier. And to write a test, we'll create another file called sum.test.js and import the sum function. We can use the test function, passing in a description for the test and a callback function for the test logic. The great thing about Jest is that the syntax is easy to follow, even for those that have never seen or written a test. So we can see that I've written an assertion here where we expect the result of passing in the arguments 1 and 2 to be 3. And if it does indeed result in 3, then the test passes. And we've successfully written a test for our function. Some other notable features that make Jest so powerful are mocking, where you can provide mock data or functions to your tests that require it. We can also produce a code coverage report, snapshots, and parallelized testing, which makes it really fast to run many tests at once. As for alternatives, Jasmine is another framework and test runner, but some things that Jasmine does not support out of the box are some of the features I discussed earlier. So snapshot tests, code coverage tools, and parallelization. Jest is actually built on top of Jasmine to provide these extra features. Mocha is a popular alternative that's less opinionated and provides just the base test structure, and thus is usually paired with other libraries like Sign-On and Chai. And QUnit was developed by jQuery, and so integrates very well with that, but unfortunately not so well with other third-party testing libraries And so a common advantage that Jest has over these other testing frameworks is its zero configuration experience while still offering so many features. And on top of Jest, we can use the DOM testing library. The key goal of testing library is to bring the tests as close to the user as possible by providing functions and methods to test the UI directly. So instead of dealing with instances of rendered components, it handles DOM elements and how they behave in front of real users. So this empowers us to conduct more powerful test cases while keeping the user experience as top priority. So let's say we build this React component, which has some simple text and an increment button, and we want to test whether or not it works properly. So how might that look like? Like before, we can write our test using the test function, passing in a description of our test and a callback function. And in this function, we're going to render the counter component that we made simply by calling the render function imported from the library. Next, we can select elements from the DOM by using methods on the screen object, such as getByText. Using this method, we can grab the DOM element with the text of clicked 0 times. We make an assertion where we expect that element to be truthy. So basically, we're just checking to see if that text is present on the rendered component. We can use that same getByText query to get the element that has a text increment, which we know is a button. So let's say we want to click this increment button 2 times. To do this, we use a click method on fire event, which is again provided by the library, and then we'll just invoke it twice. Lastly, we write another assertion where we expect to have an element that says clicked 2 times because we expect it to have incremented and display in our text. So if any of these 2 assertions that we've written failed, then the test doesn't pass. And as you can see, the syntax closely resembles user interactions because it interacts with the rendered DOM nodes. We can easily render a single component, in this case counter, grab elements within that component, and then run assertions on those elements. And so there we go. We've just written a test on a React component. So it's great that we can test individual components, but what if we want to test whether multiple components can work together as intended? So integration testing is a technique where we do just that. So continuing with DOM testing library, but in this case, if you're not a React person, then I apologize, but hopefully the point can still get across. So let's say our counter component was actually split up into 2 child components, a counter display and a counter button. They might seem more complicated now that we're passing down state into counter display and then a function into the counter button. So it might complicate our tests, right? Well, because React testing library focuses on the rendered DOM nodes themselves, we can still grab the rendered elements. For example, it's still going to boil down to rendering some text, right? Or maybe it's a paragraph or a div element. So therefore, our test is the same as before. And although we've been using it for React, the DOM testing library actually has light wrappers for some of your other favorite frameworks, such as Vue, Svelte, and even other testing tools like Cypress. Before I go on, I'd like to give some attention to Enzyme, which was developed by Airbnb and was previously the industry standard for testing React. While it's useful, the main issue is that it would test the underlying code of the components rather than the rendered DOM nodes. And so it results in testing how your code would see it as opposed to how your user would see it. To move even further out and closer to the end user, we would run end-to-end tests, which are probably my favorite because of the great automation tools that I'll be introducing. So this is where we test the entire application flow from user actions to the code functionality back to the user. And these tests are going to look a bit different. Imagine you just built out your new application and you give it to your buddy to try it out and to let you know if they find any bugs. But they've just done an end-to-end test, but manually. And it's a pain to have to do these manual tests, manual end-to-end tests so many times. Unfortunately, there are a wide array of great tools that automate this end-to-end testing. So Selenium is first on the list as it's kind of a de facto test automation framework for cross-browser testing, and also the oldest of the frameworks I'll be talking about. Selenium has historically set the benchmark for newer frameworks as it comes with complete browser support, multi-language support, high speed and performance, a huge community, and also a highly functional IDE shown on the side here. Cypress, on the other hand, is newer than Selenium, and from my experience, primarily focuses on trying to provide a good developer experience with their integrated environment. It can also be an all-in-one tool, as it can be used to write integration and unit tests in addition to end-to-end tests. And here is the Cypress test automation in action in their integrated environment, where you can see it happen in real time. And some notable features that are, that it may not be unique to Cypress, but that they offer are time travel for easy debugging in their environment. They have a selector generator that makes it easy to write the code. You can just select elements and then it'll provide you the selector that you would need to use. Real-time reloads, well-written documentation, and a faster setup compared to Selenium. However, Cypress does have some downsides as it doesn't support multi-tabs, tends to be less stable than the other options I mentioned today. Yeah, still a great option that's becoming more and more popular today. And the browser automation looks great, so it must be a pain to code out something like that, right? Well, actually not really. So here is an example of automating a login process. So we start by describing our test suite as usual. And in our function, we tell Cypress to visit, in this case, localhost 8080. Then get the username input field, type in the string admin, get the password input field, type in password 123, get the login button and click it. And that's essentially a user logging in. So it's not too bad, right? There's a simple method for almost any user interaction you can think of. And finally, Playwright is kind of the new kid on the block, just released a couple of years ago by Microsoft. It provides many of the same features as Selenium and Cypress, while also adding some improvements. Some notable features include its cross-browser, cross-platform, and cross-language support, everything support, fast execution speed, and powerful tooling with CodeGen and Trace Viewer. So here on the side, we see Trace Viewer, which, like Cypress, kind of allows you to view snapshots and individual actions for easier debugging. And while code generator tools are already out there, Playwright has one built in called CodeGen, where you can perform actions in the browser and Playwright will generate the code for each interaction. So here we see this user, we can see that as they hover, there's a selector present. You can click in the search field, type something in and showing up on the code. They'll press enter, and that's also recorded. So, it makes it a lot easier to write end-to-end tests, right? It doesn't have to be so painful. But unfortunately, with all new technologies, Playwright suffers from fewer integrations, fewer tutorials, and a smaller community. But over time, I'm sure that will change. So end-to-end test automation has really become kind of fun with these tools, right? So to summarize, tests are great. They bring reliability and maintainability to your application, but often comes with trade-offs in the form of engineering time and money. However, as we saw, whether you're writing units or end-to-end tests, there's a great tool for the job. And I didn't even talk about half of them out there. So testing does not have to be scary. And one might say that we have sort of a personal obligation to build nice things that don't constantly break and ruin the world of programming for others. But also money, because constant errors are expensive and can ruin my Japanese eraser business. So let's all write tests so that this comic doesn't it doesn't happen to us. Oops. So thank you all for your time. Feel free to connect with me on LinkedIn and GitHub.
All right. What an excellent presentation, Andrew. Let's all unmute for a moment to give him a round of well-deserved applause.
All right, Andrew. Thanks.
Wonderful. Does anybody have any questions? If you do, could you please use Zoom's raised hand feature? Cool. If not, let's all unmute and give it up for Andrew one last time.